All right, so now we count the number of degrees of freedom. Okay, we count the number of degrees of freedom. And because the wave vector can be both positive and negative, the integer n can be both positive or negative. Okay, because there is some sort of notion of direction associated with the wave vector. All right, so what we can do is that we can consider n space. Okay, so n space is the space of the integers n, and there is 1 point per unit volume. Okay, so if we just compute the volume of n space within a certain region, that gives me the number of degrees of freedom. Now, for a large cavity, we can, for large n's, we can, treat n as an approximation as a continuous variable. Okay. So what we want to do is that we want to compute how many n's there are in a volume of a thin shell whose radius is n. So n is a vector. So n is a vector of nx, ny, and nz. And of course, it's a three-dimensional vector, so we can use polar representation. And this n is the polar representation of this vector. Okay. So what we want is that we want to see what is the volume of a thin shell whose radius is n and whose thickness is dn. So we know that the surface area is 4 pi n squared of a sphere of radius n, and the thickness is dn. So this is the number of points that we're going to have in that little shell. Okay. All right. Sorry about that. Just 1 second. Yeah. So now we use the fact that 2 pi of n is equal to k of L, where k is the wave vector. Then 2 pi d of n is going to be d of kl. And therefore, what we're going to find is d of n can be translated into L over 2 pi times dk. Okay. So our thickness, our number of points within a shell, which is 4 pi n squared d of n, becomes 4 pi. Now we replace the value of n here, so it's going to be k cubed L cubed divided by 2 pi cubed d of k, right?
Sir, I think it's just k square.
It's k squared. Yeah, it's k squared. Sorry. Yeah. It's k squared. All right, cool. All right, so however, the number of modes between n and n plus dn will be twice this amount due to the two polarization of light, right? The two polarizations of light. So now see that the speed of light is c, and that's related to its frequency and k. In this fashion, of course, omega is nothing but 2 pi nu by k. So nu is kc by 2 pi. Now, if I take the variation of the differential of this equation, I get c is a constant, so I get c by 2 pi of d of k. So we can translate our formula from dk to d nu. Okay. Right. So what is going to be the energy density? So if we say U of nu is the energy density, at frequency, say nu, then the energy contained in an interval d nu around nu is going to be, we have to divide by the volume, so we have to divide by 1 over L cubed, and then we have to have multiply by 2 because there are 2 degrees of freedom. And then what we can do is then the number of degrees of freedom that we calculated was 4 pi k squared L cubed, 4 pi k squared L cubed by 2 pi cubed of dk, right? Okay, and just 1 second.
Sir, I have a question.
Yeah.
মানে আমরা জাস্ট পজিটিভ এন এক্স এন ওয়াই এন জেড এগুলো নিয়ে মানে ইয়ে না, তো আমাদের 1/8 দিয়ে ভাগ করতে হবে না, কারণ আমরা যখন শেলের ইয়েটা কাউন্ট করতেছিলাম ওখানে তো নেগেটিভ এন এক্স নেগেটিভ এন ওয়াই ওই পার্ট গুলো চলে আসতেছে, সো জাস্ট পজিটিভ যেই
I see what you mean. Yeah. Actually, I think that's a very good question. And I think what is happening here is the wave vector k is actually not necessarily positive. And because of that, we have to consider integers which are both positive and negative. But I think that's a very valid question. And can I just like think about it a little bit more and to get back to you?
Okay, sir.
Yeah, I know what you're saying. Naively, it looks like, we just have to take, but since we are coming from the point of a wave vector, and the wave vector can be both positive and negative, I think because of that, the integer, yeah. So I think that's basically what's happening.